We'll start our discussion of measures of central tendency with the mean, and this is unit 311. So we're going to do this in two parts here. The mean for data that's given individually, that means we're given all the individual numbers, and then we'll take a look at what happens if it's in the data is in a frequency table. So to start with, let's get some representation here. Let x represent a data value. All right, now just from algebra, you know that x is a variable, so we're going to have a bunch of data. Let x be any one of them. But now I'm going to subscript these, and this is pretty common in statistics or in mathematics in general. X, and then I'll use a subscript of 1. X sub 1, this represents the first piece of data, or the first number in our data set. So this 1 here is just a description of the first piece of data. So to start, let's let the letter x represent a data value. Now this is just like an x in algebra. X, you know, is a variable, so we've got a collection of data. Let x be any one of those. Now we can specify each of the values, like the first, second, the third value, by just subscripting the x. So how about x sub 1? This is the representation for the first data value. All right, so we've got a collection of data. The first one we'll call x sub 1. So all we're saying here is that this 1 is just a name for the first data value. And then x sub 2, that's going to be the second data value. X sub 3, that's the third data value. I think you get the idea. And then we can keep going, and then I'll represent it like this. X sub n, this is the nth, let's see if I can write that, the nth data value. So whatever n is, like if we had 50 pieces of data, n would be 50. If we had 300 pieces of data, n would be 300. Now here's how I get the mean. So I'm going to say this. For a sample of size n, all right, so I've got n pieces of data, and here's our sample. First piece, second piece, third piece, dot, 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 all the way up to the nth piece. So for that collection of data, the mean, now here's how we represent the mean. I've got these x's, so I'm going to write an x, and then I'm going to put a bar over it. So the mean is defined like this. All right, so x bar, now this is the average. You've probably seen these before. So what you do is you make a big fraction here. It's just the first piece plus the second piece plus dot, 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 plus the last piece. You just add up all the data values, and you divide by the number of values. Now this is a little bit awkward here. You know, see this? That's just awkward to write. So we're going to change that notation by writing this. I'm going to write it like this. X bar is equal to, I'm still going to have n in the bottom, but in the top, I'm going to write this. You see what this is here? This is the sum, right? I'm adding those up. It's the sum. So what I do is I pick a Greek letter that starts with an S, which happens to be a sigma. So I start with the Greek letter sigma, and I'm going to add up those x's. And then I have to tell you where to start and where to stop. So I'm going to run it like this. I equals 1, that's where we stop, to n, and I'm adding up the x of i's. This is called summation notation. Now, here's what this means. Let's just talk about this for a minute. I equals 1 to n of x sub I. All right, it says, as soon as you see the sigma, you're thinking sum. Okay, I'm going to add up these things. Now, what is this I? That I is called the index. All right, this is called an index. Don't worry too much about the terminology. That's called an index, and it just tells you where to start, and then you increment integer-wise right through the numbers until you get to n. So what I'll do first here is I'll start with 1, so I'll get x sub 1 plus, right, that's the sigma, Then I increment I to 2. So I get x sub 2. Sum plus, then increment to 3, plus, increment to 4, plus, dot, dot, dot. You just keep going until you get to this top number, n, and then you're done. All right, so what this says, let's just go down here now. So what this says is this. When you write this, the summation I equals 1 to n of x of I all over n, what you're just saying is add up the x's. So you get x1 plus x2 plus dot, 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 plus x of n. Just add up all the x's and divide it by n. Right, so this is just a shorthand notation for this. Now what we're going to do is this. We are always going to add up all the data. I'm always going to start with the first piece, run all the way through to the very last piece. So I'm not just doing some of the data. I'm going to do all of it. I'm going to add up all of it. So I'm going to change the notation a little bit. Instead of writing this and this, I'm just going to drop it because we're going to be adding all these up. So I'm just going to erase this, but you know what it means now. Let's erase that, and I'm just going to write this now as this. X bar is equal to, all right, add up, take the sum of the x's, divide by n. Now keep in mind what we did here. Up here at the top, this says, right up here at the top, this says for a sample of size n. So what we're dealing here with is a sample. And when you have a sample, I'll write it down here at the bottom. This is the sample mean, which is x bar, right? So x bar is equal to, could be x1 plus x2 plus dot, 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 plus x sub n, all over the sample size, or you could write it this way. X bar using the summation notation, the sum of the x's all over n. Right, so this is what you would use if you have a sample. This is the sample mean. Now, second possibility is this. Instead of having a sample, suppose we have the entire population, right? You're not just taking a subset of the population. You've got everybody here. Every number is included. So this would be, 1, the first, the second, the third, dot, 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 and then I put a capital N down here instead of a lowercase n like the sample. This would be all the numbers in the collection, not just part of them. In that case, the mean is this. Now, what we use here, you can see this looks pretty much the same as what we had before, right? What does it say to do? Add up the x's and divide by the number of them that you have. So it's really, you're going to be doing the same thing. But here's what we have now. This right here is the capital Greek letter mu, all right? And what we're distinguishing here is this. X bar, that's the sample mean, and mu, that's the population mean. And pretty much in general, if you use an English letter, you're dealing with a sample. If you're dealing with a population, you use a Greek letter. Right, so if you see a Greek letter, you're dealing with the entire population, whereas if you have an English letter, you're dealing with just a sample. Examples are always good. Let's do a couple. All right, so first of all, here's some numbers. Now, I just picked these numbers, and I put them in order. They don't have to be in order. I just put them in order so I could use them for another example here. So what have we got? We've got how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 numbers here. Now, first of all, if this is a sample, so if this is a sample, right, just a collection of some pieces of data out of our entire set, here's what we would have. X bar, now X bar we know is this. It's the sum of all the x's divided by the number of x's that you have. Now, the sum of the x's here is going to look like this. 7 plus 9 plus 11 plus 15 plus 16 plus 17 plus 21 plus 23 plus 28 all over, I think we had 9 of those, right? So this comes out now to be, you add up the top, when I did it on my calculator, I got 147 over 9, and this gave me 16.33, and then it keeps on going. So let's talk about rounding. Now, here's how we're going to round in statistics. If your number, right, what I'm going to do is I'm going to round to one place more than my original data. Now, in this case, the original data is accurate to the ones place. Right? I mean, you got 7, 9, 11. Those are accurate to the ones place. Now, I'm gonna go one place more. So I'm going to round off to the tenths. So round to the 10th. Right? So I'm going to have like something point, and I'll round to that one right there. Now, if the number's below 5, you just round down. Might just cut it off, just truncate it. If it's above 5, you're going to round up, just like normal rounding, except in normal rounding, if you have a 5, you round up. But now in statistical rounding, if you have a 5, you round to an even number. All right, so if 5, round to an even number. It's a little bit different. In normal rounding, right, everyday rounding, if it's a 5, you always round it up. But in statistics, round to an even number. So here's what we've got. We've got x bar is 16.33. Now, I'm going to round to that digit right there. So I'm going to look at this digit here. Now, that one is below a 5, so I'm just going to drop it. So I'm going to claim now that the sample mean is this, 16.3. Let's just talk a little bit more about that rounding. Suppose we had this, 18.4167. All right, now if I want to round to this place right here, I'm going to look at that digit. That digit right there is below 1, so I'm going to round this to 18.4. Now, because it's a 1, it's below 5, I'm just going to drop it. What if it was this one, 18.4667? So I still want to round to that position. So I'm going to look at that digit. Now that digit is above 5, so I'm going to round up. So over here, I'm going to round down. Here, I'm going to round up to 18.5, right, just like normal rounding that you're probably used to. But now if I had this one, 18.45, I still want to round to this. So I look at this digit. Well, that's a 5. So I'm going to round to even. All right, I'm going to round to an even number. Now this number over here, that's already even. So I'm going to make it 18.4 because that 4 is already an even number. But suppose we had this, 18.7567, say. I want to round to that digit. So I look over here, that's a 5, so I'm going to have to round to even, all right, round to an even number. Now, that 7 right here, that's an odd number. So I'm going to round up to make it even. So I'm going to write this now as 18.8. Okay, so do the best you can in remembering that. So if it's a 5, just round it to an even number. Let's do one more thing with those same numbers. First of all, we did it if we found the mean, if that was a sample. Now, if this happens to be a population, all right, so if this is a population, I'm going to get this, that the mean is going to be the sum of those x's divided by capital N now. All right, now it turns out that this is going to be the same number. So I'm just going to add up the x's. I'll get 7 plus 9 plus ... plus 28 all over. Now, it's still going to be a 9 in this case, which is still going to give us that 147 over 9. It's going to give me the 16.33. So I'm going to round this to, right, what is it? I'm going to round to that place because it's 1 digit more than my original data. The data's good. I'll do it up here at the top. Ones place, ones place, ones place is accurate to the ones. So I'm going to go to the ones place and go one more digit. So I'm going to go to the 3. Now, this number here is below 5, so I'm just going to drop it. So I'm going to round to 16.3. Now, I made a mistake here. Did you see it? The error is this. It's a population. So I don't use X bar, I use mu. There we go, and I'll just write it to make it really clear. All right, so the population mean, this is the population mean. All right, now just because I used that set of data, we got the same numbers for both the sample mean and the population mean. Now, these examples were if the data was given individually, right? You've got every individual piece of data. If the data is given in a frequency table, you don't have every individual piece of data. So we'll cover that one in the next section.